Right now, 3 space rocks are crossing Earth's orbital neighborhood. 3, within 24 hours of each other. The biggest is the size of a passenger jet. We didn't see one of them coming until just days ago. And the people who track these objects have a question they don't want to answer out loud. Because what's happening today is part of a pattern that scientists have started to notice, and one of these 3 asteroids is closer than the others for a reason we're going to come back to. Picture the screen at NASA's Center for Near-Earth Object Studies in Pasadena, California. April 28, 2026. A new dot appears on the close approach dashboard, then a second, then a third. By the time the morning shift handed off to the afternoon team, the board read like a countdown. 4 objects, 4 closest approach times, almost all within 30 hours. The largest of them, designated 2026 HX3, is 140 feet across, wider than a Boeing 737, and it is now inside the inside lane of Earth's orbital traffic. Now, the official statement is that none of these poses any danger to anyone on the ground. That's true, but the official statement leaves out the part that makes professional astronomers uncomfortable. We'll get there. First, the numbers. Earth's average distance to the moon is 239,000 miles. NASA flags any asteroid passing within 19.5 lunar distances, about 4.6 million miles, as worth public attention. Today, 3 rocks blow through that boundary. Tomorrow, a 4th. Asteroid HX3, the airplane-sized one, will pass at 1.2 million miles. That's 5 times the moon's distance. But in cosmic terms, that's a near miss. Asteroid HZ3 is house-sized, 57 feet across. Asteroid HY3 is also house-sized, 65 feet. They will pass at 1.7 and 1.9 million miles. Then on May 2nd, Asteroid GW3 follows them through. 4 flybys, 16 million miles of total close approach traffic in a single weekend. Picture this in a different way. If you took every asteroid NASA tracked passing this close to Earth in the entire month of January, then doubled it, then added a 3rd on top, that's what's happening over the next 2 days. And here's where it gets uncomfortable. 2 of these 4 objects were not in any database 10 days ago. They were discovered late last week. That's not a failure. NASA's planetary defense system is built to find big, civilization-ending asteroids years in advance. Smaller ones, house-sized, jet-sized, slip in close before our telescopes catch them. Always have. But that's not the whole story either, because something has changed about the small rock environment around Earth, and the data showing it came out 3 weeks ago. The American Meteor Society monitors fireballs, the largest, brightest meteors that streak across the sky and sometimes drop fragments to the ground. They have been doing this since 2011, quietly, consistently, with a baseline rate of large events that barely shifted year to year, until 2026. In the first 3 months of this year, the AMS recorded a doubling of large fireball events worldwide. Not a 5% uptick, not a margin of error, a doubling. The statistical odds of that happening by chance are about 1 in 21,000, and the fireballs are not coming from a known meteor shower. They are coming from a specific patch of sky, twice as densely as ever recorded. NASA researcher Patrick Schober traced part of this surge to its source. A small asteroid, somewhere out there, broke apart from the heat of getting too close to the sun. 282 of those fragments have already hit our atmosphere this year, and that is from one disintegrating rock. We don't know how many other rocks are doing the same thing right now. So when NASA's dashboard lit up this week with 3 asteroids on a 24-hour close approach schedule, it wasn't completely random. Some of these objects come from populations we are only now starting to understand. They cross Earth's orbit on steeply inclined paths that traditional surveys have struggled to catch. The closer we look, the more of them we find. And the part the official statement leaves out is this. Of the roughly 41,000 near-Earth asteroids we've cataloged so far, an estimated 40 million more, under 30 meters across, remain undetected. Most of those would burn up if they hit our atmosphere, but not all of them. Let that sink in. On February 15, 2013, an asteroid 60 feet wide entered Earth's atmosphere over the city of Chelyabinsk, Russia. It exploded 30 miles up with the force of about 30 Hiroshima bombs. The shockwave shattered windows in 6 cities. Around 1,500 people were injured, mostly by flying glass. We had zero warning. The rock came in from the direction of the sun and was invisible to telescopes until the moment it lit up the morning sky. 60 feet, the same size class as one of the rocks passing us this weekend. The good news is that today's 3 asteroids are nowhere near a collision course. Their trajectories have been calculated, modeled, and remodeled. The math says they pass us cleanly. The bad news is the math could only be done because we found them in time. The next one we don't see, and there will be a next one, is what keeps planetary defense researchers up at night. So what's actually being done about this? More than people realize. In November 2022, NASA's DART spacecraft slammed into a small asteroid moon called Dimorphos and changed its orbit. That was the first proof in human history that we can deflect an asteroid if we see it coming. The Vera Rubin Observatory in Chile started full operations last year. Its first dataset alone produced 11,000 new asteroid detections. Astronomers say there are tens of thousands more waiting in the pipeline. The Surveyor, the first space telescope built entirely to hunt hazardous asteroids, launches in 2027. By the end of this decade, the night sky will be the most thoroughly monitored it has ever been in human history. But here's the part that nobody at NASA's press office wants to put in a quote. We are still playing catch-up. The detection net is getting wider every year. The objects we're catching today, like HX3 and HZ3, are objects we would have completely missed a decade ago. That's good news. It also means a decade ago we missed everything in this size class, and we don't know what passed us. Remember the question I said the people who track these objects don't want to answer out loud? It's this. If 3 asteroids in 24 hours is what we can see now, with the best telescopes humanity has ever built, what was the actual rate of close approaches when we couldn't see them? We don't know, and the data from the Fireball surge suggests we may have always been in busier traffic than we thought. There are 2 ways to frame what's happening this weekend. The first is reassuring. 3 known asteroids, 4 flybys, all calculated, all safe. The system is working. The second is the one that probably keeps Patrick Schober and his colleagues focused on those all-sky cameras. Today is what we see. We are still working out what we don't. By tomorrow morning, the airplane-sized HX3 will be past us, on its way back into a long, lonely orbit around the sun. The 2 house-sized rocks will fade into the background of space. May 2nd, 2026 GW3 follows. The next batch will be tracked, named, and announced when our telescopes spot them. Some of them will get more than 3 days of warning, some will not. That's the deal we have made as a species with the rocks that share our orbit. Watch what we can, calculate what we can, hope we see the dangerous ones in time. The Chelyabinsk meteor was about the same size as one of the asteroids passing today. The difference between a near miss and a small city of broken windows is, in many cases, a matter of timing. Which side of Earth's orbit the rock crosses on a given day. Today we got lucky 3 times. If you remember Chelyabinsk, the dashcam videos, the streak of fire across the sky, the sonic boom 45 seconds later, you know what a 60-foot rock can do when nobody sees it coming. We tell ourselves we'll do better next time. The truth is, we are doing better. We just aren't done yet. So here is the honest question. NASA's official line is that none of these 3 asteroids poses a threat. That is true, but if a 60-foot rock the size of HZ3 had come in on a slightly different angle today, and we had only 72 hours of warning, what would you have done with that warning? Where do you go? Who do you tell? Would 72 hours even be enough? I want to hear it, honestly. Not the action movie answer, the real answer. Because that is the question planetary defense researchers ask themselves every time the dashboard lights up. And it is the question that decides whether the next Chelyabinsk is a story about luck or a story about something we did about it in time. 3 rocks, 24 hours. The universe doesn't ask us to be ready, it just asks us to be looking. We are looking. The question is whether we are looking fast enough.